There's a war being fought every single day, all around us, and even inside of us. It's this silent, invisible battle against microscopic invaders that want to make our bodies their home. So today, we're going to dive into that hidden world of infectious disease. It's a fascinating question, right? Why do we use those different words? Well, the answer really gets to the core of what we're talking about today. See, something like heart disease, that usually develops from a mix of things like your lifestyle, your genetics, maybe just aging. It kind of comes from within. But a cold? Oh, that's totally different. That's a full-on invasion. You catch it from an outside attacker. And that just sets up a completely different kind of fight. All right, so to really get a handle on this whole battle, we've got to start by identifying the enemy. What is it that makes a disease infectious? Well, it really all boils down to one simple idea: invasion. So here's the official definition. The key things to pull out of this are: 1, it's caused by some kind of outside agent; 2, that agent actually harms you; and 3, you can pass it on to someone else. Any microorganism that does all that, we call it a pathogen. But not all pathogens are playing the same game. You've got your true pathogens. Think of these guys like a battering ram. They can pretty much bust through the defenses of any healthy person. Then you've got the opportunistic pathogens. Now these are way sneakier. They're more like a burglar who waits for you to leave a window open. They tend to strike when our defenses are already down, maybe in older folks or anyone with a weakened immune system. Okay, so let's meet this rogues gallery of microscopic invaders. You might be surprised by just how much variety there is out there. And believe me, they all have their own unique battle plans. So here's the main lineup. We've got bacteria, viruses, fungi, protozoa, helminths, and even something called prions. Each one is its own unique kind of enemy, from tiny single-celled organisms all the way to, well, weird infectious proteins. Now, we could spend all day on this, but for this explainer, we're going to zoom in on the two you probably hear about the most: bacteria and viruses. All right, first up on the list, bacteria. These guys are everywhere, and most of them are actually harmless or even helpful to us. But of course, there's always that small group that gives the rest a bad name, the ones notorious for causing all sorts of diseases. So what are bacteria? Well, they're these really simple single-celled life forms. The technical term is prokaryotes, which is just a fancy way of saying they don't have a nucleus. But don't let that simplicity fool you. They are incredibly efficient machines. They reproduce by just splitting in two. It's called binary fission. And because they can do this so fast, it explains how diseases like strep throat, or even something as devastating as the plague, can spread and take hold so quickly. Okay, next up in our rogues gallery, viruses. And these things are a whole different ballgame. They're so weird, in fact, that scientists still argue about whether they're even technically alive. So, picture this. A virus is basically just a little snippet of genetic code, either DNA or RNA, all wrapped up in a protein shell. That's it. It can't do a single thing on its own. It's completely inert until it finds a host cell. Then it's like a pirate boarding a ship. It latches on, injects its genetic material, and completely hijacks the cell's machinery, turning it into a non-stop virus-making factory. And that hostile takeover? That's what's behind everything from a simple common cold all the way to influenza and AIDS. Okay. So we've met a couple of the main culprits, but how do they actually do it? How do they make us sick? Well, it turns out they follow a pretty consistent 4-step battle plan. Step 1, they gotta get inside the body, right? Through your mouth, nose, a cut in your skin, any opening will do. Step 2, they have to stick to our cells. This is super important for them to get a foothold. Then, step 3, they invade and start to colonize, basically building up their army. And finally, step 4, they inflict the damage. Sometimes it's just by overwhelming us with their numbers, but a lot of the time they do it by releasing these nasty toxins or enzymes that wreck our tissues. And this brings up two really important words you hear a lot: contagion and virulence. Let's look at polio. It's highly contagious, meaning it spreads super easily. But the good news is most people who get it don't get seriously ill. Now, flip that and look at Ebola. It's not nearly as contagious. It doesn't spread through casual contact, but it is incredibly virulent. And that means if you do get it, it's very likely to cause severe disease. So, contagion is how easily it spreads. Virulence is how nasty it is. But hold on, this isn't a one-sided fight. We are absolutely not defenseless. Our bodies have this amazing, super sophisticated, multi-layered defense system that's designed to fight off these invaders 24/7. So let's take a look at our internal army. So think of your body's first line of defense like a medieval fortress. Your skin, that's the giant outer wall. Your tears, your saliva, all that mucus, that's the moat, and it's filled with enzymes that can destroy invaders. Then you've got these little guards patrolling the walls, called phagocytic cells. These are a type of white blood cell, and their job is to literally eat any intruders they find. And get this, even the good bacteria that live on and in us, our normal flora, they act like loyal citizens of the castle, fighting off invaders for space and food. But what happens if an invader actually gets past those walls? Well, that's when the body calls in the special forces, the specific immune response. This isn't a general defense. This is a targeted strike. It all kicks off when a type of scavenger cell, a macrophage, gobbles up a pathogen. It then takes a piece of that invader, an antigen, and puts it on its own surface. It's like it's holding up a wanted poster. This poster alerts the elite soldiers, the T cells, who act like battlefield commanders, coordinating the attack, and the B cells, who are the weapons factories, churning out millions of tiny guided missiles called antibodies. And honestly, here's the most incredible part of the whole system. After the battle is over and we've won, our immune system doesn't just forget about it. It creates memory cells. So just like the quote says, the next time that exact same pathogen tries to invade, these memory cells are ready. They recognize it immediately and just unleash a massive, super fast flood of antibodies. This whole process is what we call immunity. It's the reason you typically only get something like chickenpox once in your life. This whole natural defense system is just brilliant, isn't it? And what's even more brilliant is that we humans figured out how to kind of hack it, how to give it a helping hand. And that's led to our entire modern medical counterattack. And of course, I'm talking about vaccination, which is easily one of the greatest achievements in public health ever. What a vaccine does is it introduces your immune system to a safe version of the pathogen. Maybe it's killed or weakened or just a tiny piece of it. It's not enough to actually make you sick, but it's totally enough to trigger that training exercise. Your body learns, it builds those all-important memory cells. It's exactly like giving your army the enemy's complete battle plan before the war even begins. You know what's really cool is that vaccination doesn't just protect you, it protects everyone around you. We call this herd immunity. Think about it. If a huge chunk of the population is immune, the pathogen just runs out of places to go. It hits a dead end everywhere it turns. It can't spread, the chain of infection gets broken, and that protects the most vulnerable people in our society, the ones who can't get vaccinated for medical reasons. But despite all this incredible progress, this war is nowhere near over. In fact, the battlefield is constantly shifting. New threats are always emerging, and our old enemies are constantly learning new tricks. And here's a strange kind of paradox. Sometimes our own progress accidentally creates brand new problems. I mean, look at this. Reforestation is great for the planet, right? But it also brings us into closer contact with ticks that carry Lyme disease. Air conditioning is a lifesaver in the summer, but those systems can also spread Legionnaire's disease. The point is, as our world changes, the diseases we have to fight change right along with it. And this leads us to what might be the single biggest threat we're facing today: antimicrobial resistance. This is literally evolution happening right in front of our eyes. Think about it. When we use an antibiotic, it wipes out most of the bacteria. But there might be a few that, just by sheer luck, have a natural resistance. Well, they survive. And then they're the ones that multiply, passing that resistance down to all their offspring. Penicillin used to be a miracle drug, but now, some strains of staph bacteria just laugh at it. Our enemies are getting smarter. Which brings us to the big final question. This isn't a war we can just win and be done with it. It's a constant, never-ending arms race. As these microbes are constantly evolving, the real question is, how will we? The greatest challenge for all of us is making sure our science, our technology, and our strategies can keep up and maybe, just maybe, stay one step ahead.